Cisco StackWise Virtual, enhancing network resilience. StackWise Virtual, SVL, is a network system virtualization technology that pairs two Cisco Catalyst 9500 series switches together, creating a single logical network entity from two physical switches. This technology significantly improves network resilience, simplifies management, and eliminates potential bottlenecks. By creating this virtual entity, StackWise Virtual provides non-stop communication with increased bandwidth and scaling capability while maintaining operational simplicity. It's designed to deliver high availability and fault tolerance in mission-critical networks. Understanding StackWise Virtual architecture. Dual home design. StackWise Virtual creates a loop-free topology by connecting two physical switches into a single logical entity. This enables dual-homed connections to access layer switches, servers, and other network devices, eliminating spanning tree protocol dependencies. Control plane unification. The technology merges the control planes of both switches, creating a single control plane that manages the entire virtual system. This means protocols like OSPF, BGP, and STP run as a single instance across both physical switches. Data plane integration. The data planes of both switches are unified, allowing traffic to flow optimally through the virtual system. This integration enables load balancing across all available paths and provides redundancy in case of link failures. Key components of StackWise Virtual. StackWise Virtual Link, SVL. The SVL is the special connection between the two physical switches that carries control and data traffic. It's the foundation of the StackWise Virtual system, enabling the two switches to function as a single logical entity. Dual active detection, DAD. DAD mechanisms prevent both switches from assuming the active role simultaneously in case of SVL failure. This prevents network loops and inconsistent forwarding states that could disrupt network operations. Multi-chassis Ether Channel, MEC. MEC allows Ether channel links to be distributed across both physical switches, providing load balancing and redundancy. If one switch fails, traffic continues to flow through the remaining links on the other switch. StackWise Virtual Link configuration. Enable StackWise Virtual. First, enable StackWise Virtual mode on both switches and assign a domain ID. This is done using the command StackWise Virtual in global configuration mode, followed by domain 1 or another domain number. Configure SVL ports. Identify which ports will form the StackWise Virtual link. On the Catalyst 9500, use 40G per 100G ports for optimal performance. Configure these ports using StackWise Virtual Link 1 in interface configuration mode. Configure DAD links. Set up dual active detection links to prevent split brain scenarios. This is done with the command StackWise Virtual Dual Active Detection on the selected interfaces that will connect the two switches. Save and reload. Save the configuration and reload both switches to activate StackWise Virtual. After reboot, the switches will form a single logical entity with one active switch and one standby switch. Failover scenarios, switch failure. Normal operation. During normal operation, one switch functions as the active switch handling all control plane operations, while both switches actively forward traffic. The StackWise Virtual link carries control traffic and data traffic between the switches. Switch failure detection. If the active switch fails, the standby switch detects this failure through the absence of keep alive messages. This detection happens within milliseconds, triggering an immediate failover process to maintain network availability. Standby promotion. The standby switch immediately assumes the active role, taking over all control plane functions. Since it already has synchronized state information, it can continue operations with minimal disruption to the network. Traffic rerouting. Traffic is automatically rerouted through the remaining active switch. Since multi-chassis Ether channels, MECs, have links connected to both switches, traffic continues to flow through the remaining links on the functioning switch. Failover scenarios, SVL failure. 1. SVL link disruption. If the StackWise Virtual link fails, the two physical switches can no longer communicate with each other. This creates a risk of split brain scenario where both switches could assume they should be active, potentially causing network loops. 2. Dual active detection. The dual active detection, DAD, mechanism activates to prevent both switches from assuming the active role simultaneously. DAD uses dedicated links or protocols like enhanced PAGP to detect this condition. 3. Recovery action. When a dual active scenario is detected, one switch will shut down its non-SVL interfaces to prevent network disruption. This switch enters a recovery state while the other continues to forward traffic normally. 4. SVL restoration. Once the SVL is restored, the switch in recovery mode will reload and rejoin the StackWise Virtual domain as the standby switch. The system then resynchronizes and returns to normal operation. Failover scenarios, interface failure, link failure detection. When an interface fails on either switch in the StackWise virtual domain, the failure is detected immediately. Since both switches function as a single logical entity, they share interface status information across the SVL. MEC redundancy. If the failed interface is part of a multi-chassis ether channel, MEC, traffic automatically flows through the remaining active links in the channel. This provides seamless redundancy without requiring spanning tree protocol reconvergence. Routing adjustment. For routed interfaces, the unified control plane automatically updates routing tables to use alternative paths. Since both switches share the same routing information, this happens without requiring full routing protocol convergence. Interface recovery. When the failed interface recovers, it's automatically reintegrated into the active topology. For MEC interfaces, traffic begins load balancing across all available links again, optimizing bandwidth utilization. Best practices for StackWise virtual implementation. 1. Redundant SVL links. Configure multiple SVL links using different line cards or modules to prevent a single point of failure. The Catalyst 9500 supports up to 8 SVL links for maximum redundancy. 2. Bandwidth planning. Use high bandwidth interfaces, 40G per 100G, for SVL connections to ensure adequate capacity for both control and data traffic between the switches. 3. Multiple DAD mechanisms. Implement more than one dual active detection method when possible, such as dedicated DAD links and enhanced PAGP, to ensure split-brain scenarios are always detected. For regular verification, periodically verify the health of your StackWise Virtual setup using commands like show StackWise Virtual and show StackWise Virtual link to ensure all components are functioning properly.